Accumulation function. Now, what I'm doing is I'm constructing this course according to the topics that we have on the SOA website. So let me show you. So you see the first topic here is interest rate, and that was my first lesson. And then the second topic is simple interest. That was my second lesson, if you remember. Third topic is compound interest. That was my third lesson. And the fourth topic is accumulation function, which is my current lesson, the fourth lesson. Now, although this topic of accumulation function is mentioned in the syllabus here, yet the sample problems which they have on their website doesn't contain any problem which has accumulation function or which asks you to find accumulation function. But still, for the sake of completeness, since it's in the topics, so we will briefly go over it. And the accumulation function is actually the ratio of the accumulated value of an account to its original value. So the ratio of the accumulated value to the principal. So if P is the principal and it grows to an amount A of t after time t, then the accumulation function little a of t is given by little a of t is equal to the amount at time t divided by the principal. Okay, so let's see how we calculate accumulation function in different settings. First, let's do it for simple interest. So we know that for simple interest, the amount formula is a of t equals p times 1 plus it. And if we divide by p on both sides, because we are trying to find the accumulation function, which is a of t divided by p, so you divide by p on both sides, so you just get 1 plus it. So that means that in this case, little a of t is equal to 1 plus it. So the accumulation function for compound interest is 1 plus it, or for simple interest is 1 plus it. So next we calculate the accumulation function of compound interest. So here we know that the formula for the amount is a of t equals p times 1 plus I power t in the simplest case where the compounding takes place only once a year. So if we divide both sides by p here, we get again at over p is equal to 1 plus I power t. And you know that at divided by p is the accumulation function. So in this case, the accumulation function is 1 plus I power t. Okay, so let's look at an example. So for any accumulation function a of t, calculate a of 0. And that's a very important example because the a of 0 that we will get here, it turns out that that is that works for every kind of interest. So right now we calculated accumulation function of simple interest first, and then we calculated accumulation function of compound interest. But you could have different kinds of interests, and for each of them you can calculate the accumulation function. But it turns out that no matter what the type of interest is, a of 0 will always be the same for all of them. And let's see what that would be. So we first note that a of 0 is the amount at time 0, which is just another way of describing the principal. So actually, the principal can also be denoted by big A of 0, because principal is the original amount, which means the amount at time 0. And we know that A of t is equal to at by p. So a of 0 would be a of 0 by p, and a of 0 is just p. So it's p by p equals 1. So it turns out that little a of 0 is always 1, no matter what the underlying type of interest is. And that's an extra thing we found. We had some practice finding an accumulation function, and we learned a very a universal fact that little a of 0 is always 1.